So going back to FRQ4, right? We already went over the natural logs, right? How to condense and expand, right? What I want to focus on is the identities, right? I'm just going to show you one example for now, and hopefully you guys understand it. So if you look in part A, right? Section 2, rewrite h of x as an expression in which secant appears once and no other trig function is involved, right? So if I look at my trig, I have tangent, cosecant, and cosine, right? There's no secant. So for this one, you guys have to know your identities. I think I gave you guys about 12, more or less, the most popular ones to try to memorize. So hopefully you guys do, alright? Because this one is not as easy as it appears to be. So here we go. Tangent, I'm thinking quotient rule. Quotient rule for tangent, it has two. It has reciprocal or it has quotient rule, right? So tangent, I can switch it to sine of x over cosine of x, right? And then again, I want to end up with sine and cosine for the most part, right? So cosecant, I can do the reciprocal identity. It's going to be 1 over, if I have c here, I need s over here, so sine is reciprocal. And then we'll cosine it, we'll leave it as cosine, right? So now, where do I go from here? I have the main one, sine and cosine, right? So one of the things you can do is, I don't know if you're noticing, I have sine here and sine down here. So those two sines, if I have it on top and the bottom, they're going to simplify to 1. So I'm left with 1 over, well, cosine of x over cosine of x. So I have a fraction within a fraction. So now, what could I do? Well, to try to get rid of the second fraction, the bottom, multiply by its reciprocal. So wouldn't that be 1 over, well, cosine? So what I do to the bottom, and which just converts to 1, I'm going to do to the top, 1 over, well, cosine of x. So now I'm left with 1 over cosine, and since I'm multiplying them, I'm squaring it. It's basically saying that you have x times x, right? But in this case, you have cosine times cosine. And then just take the reciprocal of cosine. If I have a c, I'm left with, well, secant. And since I have a squared here, keep the square there. So that's pretty much it, alright? So again, we started off with going based on your sine and cosine and just simplifying from there. So hopefully you guys understood those two identities, right? Quotient and reciprocal. Good luck.
And go.
So let's continue with FRQ4, right, and the identities, right? So notice here that in this example, on part A, h of x has the trig, right? I have sine 2 of x over sine of x, right? So you're probably thinking, sir, can I just simplify and then just end up with sine? The answer is, well, no, right? Because what you have here is what we call a double angle identity because of that 2 inside the parentheses. So you have to remember, for the double angle, I told you guys, for sine of 2x, you're gonna have 2 times sine of x times cosine of x, and the bottom we're gonna leave it by itself, sine of x. Alright? So now, how could I simplify this? Because the question is asking us to rewrite h of x as an expression in which cosine appears once and no other trig functions are involved. So we have the cosine there, and notice how on the top I have sine, and on the bottom I have sine. So wouldn't that just simplify to just, well, 1? And it's a horrible one. Like a 1, and the answer is yes. So you're left with 2 times, well, cosine of x. And that is literally it. That's how easy it could be, just as long as you know that this is a double angle identity. Sine of 2x, again, 2 times sine times cosine.
Go.
So, look at this example. Third example, right? So here, we also have a double angle identity, right? And this one is involved on section, well, B. It's no longer A, right? But they're still showing up, the identities. So now here, it's telling me to rewrite k of x just involving cosine. So here it is, right? So what can I do from here? So you have to remember what's the, I'm gonna put it over here on top. And let me rewrite this. Sine of 2 of x times sine of,
Sorry.
okay?
Sorry.
see my cameraman over here, or woman, sorry. So now, again, you guessed it, right? Double angle identity, so I have 2 times cosine of x times sine of x, right? Times sine of x. What in the world do I do here? Well, try combining. So you see everything's being multiplied. So think of this as x times x. If I have x being multiplied times x, you have, well, x squared. But here we have sine and sine. So doesn't this become just sine whole squared of x? Cosine of x, and then times 2. But now, our goal is to leave just the cosine. So how could I get rid of the sine squared? So we're gonna do a little side quiz, and you have to remember that sine squared of x plus cosine of x, which is both of them are squared, is equal to 1. And this is involving the Pythagorean identities. So how do I leave the sine by itself? Well, minus cosine squared minus cosine squared of x, right? This becomes 0. So sine squared of x equals 1 minus cosine squared of x. So why did I do that side quiz? Well, basically it's because if you notice here, this and this is the same thing. So now can I just replace the sine squared with 1 minus cosine squared? And the answer is
Yes.
exactly. Alright. So 1 minus cosine squared of x. And you can leave it there, or you can start distributing it if you want to, right? In the example that I'm seeing, on the solution menu that I'm seeing, they distribute, right? So how would that look like? So you have 2 cosine, basically distributing here, distributing there. So I have 2 cosine of x minus 2 cosine. There's 1 here, and there's 2 over here, so doesn't that mean we have 3? Yeah, basically. Or vice versa, right? You could just factor out, like, you can have this one on top and this one on the bottom, doesn't matter, but this is basically your answer. It could be the one on top or the one on the bottom, and we'll leave it like that, right?